We're live. Hello, world. My name is Alan. We're practicing LeetCode today. And we have a medium level problem. Let me share the screen and restart the clock. Restart. Okay, so I took a quick look at the problem. Luckily, the description is pretty short. What do I understand so far? There is a matrix grid, n by n. Okay, so it's a square. Return the number of pairs such that row and column are equal. So that means, for example, in this matrix, there is this 277 row or column equals this 277 row, and that's the only pair. In the second example, there is 2422, and there is the same column, and the same, and another row is the same. So it's the column is 2, but the row. Wait a second. Wait a minute. Row. No. So row 0 and column 0, 3, 1, 2, 2 are equal. Yes. Okay. So that's one pair. Then, and there is two pairs. 1, 2. Yeah. So, okay. Yeah. 2 and 3. Yeah. But there is also this. So this, and then there's this 3, 1, 2, 2. Okay, I'm just marking it in my notebook. Okay. Now, all we need to do is identify those pairs and return the number of those pairs. Yeah, but if they contain the same elements in the same order, equal array. That is an equal array. Okay. Well, let's look at some. Do I see what type of question that is? It was, yeah, that was in the hash map category. Hash map. So, yeah, and what are the constraints? It's a square. There is up to 200. And the values are all positive, but up to 10 to 5. Okay. Well, 10 to 5. 10 to 5. Okay. If we create I mean, what's let's look at the most yeah, the brute force is, we'll look at this row, 1, 2, 3, 4. Okay, elements one by one. And basically we want to know, is there for this, or for this row, is there a column that is equal? And the brute force would be to like, there is a 3. We go and yeah, to do comparison one by one, value, yeah, item by item with each. So we'll compare. Yeah, this one will be, yeah, we'll take 3 and 3, 1 and 1, 2 and 2. Yeah, we'll take 3 and 1, not equal, take 3 and 2, not equal, take 3 and 2, not equal. Okay. Okay, so we've found one pair, but that's it. And then we'll do the same for the next one and the next one and the next one. And by the way, that is yeah, we'll need to go n for each. Well, in the worst case, this could be pretty much going. So that's a linear operation. This comparison will take n steps for each comparison. Yeah. Right. So it will be n squared for each row. If there is one row, it takes, yeah, n steps to compare it with one column. Yeah, n squared, and we have n rows, so it will be basically n brute force will be n, yeah, by n, so n cubic, which is not too terrible actually, because it's, what is it? It's just in the worst case with these constraints, it's just 200. So it will be 8 8 million operations. The brute force with these constraints, yes. But obviously we can improve on that, and one way to do that is to create to create maps, columns and rows. Basically we need two sets. Oh no, we can't use sets. Well, we can use maps, yeah. For maps, so we'll because some we might have repeating values. Yeah, we can store arrays, and arrays are comparable. Yeah, we can have arrays. So that will be rows will be a map of it will be a map of what? Of arrays of length grid integers and yep, so that will be rows, and we'll know how many, so we'll know that there is 2 of these. Yeah, we'll just count. If this row exists, we'll count them. This way we can go over these maps. And by the way, we need to go only over one of them and check if that specific value repeated in the columns, like this this row. There is 2 rows, and if it's repeated in the columns once, we can multiply 2 by 1. If it's twice, then we'll have this will be a pair with that, this will be a pair with that, and so 2 by, yeah, we just multiply their values if they exist, but we can compare them. So that's row count, not row inventory, and that's columns inventory. Because this is like how many times this row is repeated. Yep, that using some memory, we will be able to in constant time do our calculation. Yeah, we just need to fill this map with them first, and then we'll just go through the map once and get through the rows once and get our results, get our number of pairs. Yeah, filling them up. To fill them up, we just need to go over the grid once. Yeah, also. So that's basically the optimization with the hash map to actually not only to get not cubic and not even square and square time complexity. We'll get linear time complexity. Well, we do need to go over, I mean, to go over the grid, it's an in this case, n square operation. Yeah, but yeah, so it is an n squared though. Yeah. But to go over once, but we would only have to do it n times. Yeah, this full traversal. So basically, that's the solution. I don't know. It looks pretty simple so far. I don't know what's the catch. What do we need to do? I mean, we can compare. Yeah, the as long as as array comparison is if is a fixed time, constant time operation, and I don't really know if it is, but I don't know the mechanics of array comparison in Go, like equality for equality. I don't really know. So I could look that up, but I'm assuming it is constant time. Yeah. And you can use it as a key in a map. So, I mean, both solutions, the brute force and the hash map solution, both of them are, I mean, within both of them. I think both of them will be accepted. Should be accepted, yeah. That's how I feel about it. Is there a more some kind of smart way, some kind of magical way, there could be some magical way without memory. Could be to compare them without extra memory. Like, I don't know, what can you do? You need to make sure there is these numbers in the same order. Equal array. Check for equality. Okay, let's implement this more efficient one, I guess, for this practice. And this looks like a good warm-up solution, warm-up question, I would say, interview question. So this will be n square. Yeah, so we need to fill up those rows and columns. To do that, we need to go over, well, we need to go over each row first, and then over each column, and fill them up. So, not inventory, but inventory. Well, you do need to go over for, geez, that's gonna be like, yeah, row 1, row 2, and then the same thing for columns. Well, it's gonna be, yeah, a couple of nested. It's gonna be for row. range grid, basically. That will give us from 0, column, range, pretty much the same grid, but it doesn't matter because they're square. So yeah, so now we're gonna take grid, row, column, and I'm gonna say that row, we're gonna create an array of length. By the way, let us remember that n is length of grid. Okay, so we don't have to like let me fix, yeah, n integers. Yeah, we actually had a typo here. N integers, yeah. And here we just, yeah, we're gonna arrange n and also arrange n. Row is an array of integers that's gonna be created. Yeah, by the way, we can even use the more, I don't know if it's more correct or not. It's just, we'll create those maps. So that's an array. Row is an array of those integers, and we're gonna say that, we're gonna fill it up though, basically. Yeah, so that's the value, and we say that row at this index is that. And after that, we're gonna check. Okay. We actually don't have to check. We can say that row inventory for this row plus plus whatever the number we have of these rows. Yeah. And yeah, so we'll count these rows in our inventory. Same thing for column. Now, yeah, we're gonna go that column. Yeah, this way we're gonna go over the, we'll take column 1, the first column. It's gonna go over its row, yeah, over its values, yeah. So now, this, by the way, seems like a repeating operation, so we could create a function for that, but then all we need to do is go over for, yeah, we need to count pairs count equal pairs count is 0 equal. And we're gonna say that we're gonna go over keys and values, range row inventory. So now we're gonna check. Well, basically, if it's a 0, so we have some kind of number here of these. And we're gonna say that, yeah, we basically can tell that, yeah, this count is this value multiplied by how many times that happens, that columns inventory happens. So that array yeah. And we add it to our count and we return the count. Yeah, basically it's like that. So I think it should be that. Array length. He doesn't like the array length. To be n. Why is it so? Length of the grid. What's the problem with n being do we need to make it a constant? That's what I'm thinking, yeah. I'm thinking it doesn't like it. But I mean, we can create a variable. What's the problem? Yeah, it could be a variable invalid array length n. And the same thing happens here. But why is it not valid? N could be 1, could be 200. So n is pretty clear. So that's the type. Create a map. It's gonna have arrays of integers as its type, as its key. Arrays of this length as its key. Yeah. I mean, what else? Yeah, maybe there is some syntax I'm missing here. Because obviously it doesn't like, yeah, n is an integer, but doesn't seem to like it. If we put like 5 here, yeah, now it has a problem here, but yeah, it likes 5, but it doesn't like the integer for some reason. Why is that? What about if we put that instead of value of time must be constant. Yeah, it must be constant. So how do we create a constant? Oh, the array length will be defined at compile time, I guess. Go array length at compile time. Must be constant. I think it's because it's defined at compile time. Because it's, yeah, because that's why it has to be constant, I guess. Length. Yeah, so Reddit, you can't, is not known at compile time. You need to build a slice instead. Well, the problem is with a slice, we can't compare them. So it looks like arrays, wow, they are built in Go. Their length is defined at compile time. So you then get a program that only knows not expose dynamically sized arrays to users the same way. So this, you don't need to specify the capacity is the same as the size. Reddit is yeah, so it looks like I'm having fun with this because yeah, I think length defined at not at runtime, but at compile time. Yeah. Yes, in Go, the length is defined at compile time. Here is why part of the type. So this is the type, and it's just gonna be, yeah, this program will only know how to work with the, yeah, this program will not be able to, yeah, depending on the input, yeah, it will not be able to handle other lengths. So, but that breaks our entire idea, because I don't know how, if we can compare the, because slices you cannot compare. Yeah. You can compare arrays. And arrays. Interesting. So we want a program that can compare. I'm thinking we should go back to brute force, because but how can we use hash map then? There is an idea. Why don't we create arrays of the length 200? Yeah, because we know the length max is 200. Yeah, so then Oh, yeah. If we have unexpected, oh, I think we're missing something. So, yeah, I mean, it looks like the grid doesn't have let's do it a different way. Let's say that n is still length, but the yeah, the grid is still n, so that's how far we will go in our rows and columns. But for comparison, max, we'll use the max length const max length of those columns or is 200. So yeah, that we can put here. Yeah, we just need to make sure we create those. Yeah, we'll fill them up. We're not going to use all of that memory, but we'll have it ready. Okay, so the output is 0. Okay, what could be the problem here? Okay, it's always 0. It never finds any match. So it goes over the rows. And okay, it looks at the specific number and it checks, okay, how many of these? Yeah, when the column is created, this array is created before it's put. It's all of the default value is 0. So call value of each item. The array is 0, and so it never finds any equal values. Interesting. By the way, that's big O time. And okay, so columns. My first idea is to print both the row. Oh, I think, geez, I need to, yeah, I forgot that, yeah, we need to column inventory, yeah. It should be working now because it was empty. It was empty, yeah. Nice. So it should be working. Yes, we are using a bit more memory, but with speed, we're just beat everything. And with memory, we're not too bad. Not too bad. But really good speed. And by the way, I think you even can create map of certain length also. We might not use all of that, but it's we like can allocate that length. Yeah, so it doesn't have to create it. Now it's 9 milliseconds. Well, it's I don't think it's there is any difference, but it's pretty quick. Yeah. Well, that's the solution to the medium level problem. I wonder what the hints were. We can use nested loops to compare every row against every column. Okay. Another loop is necessary to compare the row and column element by element. Yeah. Possible to hash the arrays and compare the hashed values instead. Yeah, so hash an array, hash map. Well, that's what essentially a map will be doing. Oh, yeah. If we just create a hash for this specific array, I'm not sure I remember or I know how to hash an array. It's a good question. How to hash an array. Hashing a data structure. This method is commonly used in databases, caching systems, and various programming applications to optimize search and retrieval operations. The great thing about hashing is we can achieve all these operations, search and sort, in O1 time, big O1 time on average. List. Well, how to hack? No, how to hash an array? Because I mean, I have some idea of how to hash a number. Like, yeah, for example, you can use remainder as a hash function. Yeah, so, but if you have an array of 200 numbers, how to create a specific hash for that. That hash and yes, also another follow-up question I had was, Golang how arrays are compared for equality. No, I want to know the time complexity of it. Scan time comparing arrays comparing the comparison iterates through each element of both arrays, checking for equality. Therefore, the I'm not sure that's correct. Okay, time complexity of comparing arrays in Golang. I mean, the problem is if they're compared iteratively, then how would them, or even if the hash function, like when you show an array, because when we do that and when we say like, okay, is this array, this k, this array, is it in this hash map? If the program has to go over that array, that is an n square operation. Oh, that is a linear, the big O n operation. Because we have, or on the other end, because if the key is already a hash, so to hash the arrays, if we can actually hash them and not, because what is the key here? It's an array. So I'm not even sure we're actually getting, because I need to understand what happens under the hood. To compare two arrays, you can use reflect deep equal function from the reflect package. So we compare the elements. I assumed for some reason. I assumed because that when a Go program compares to arrays, I thought it was a constant time operation. I thought because they can be used as keys comparable. So they're comparable, so they can be used as keys. And I thought it's a constant time operation, like check if this array is. What it will do, it will create. It will pass it through the hash function, get that hash, and check its hash table if it's there, if that hash is there. And we can do that manually. I just don't know how to hash the arrays. It is also possible to hash the arrays and compare the hashed values instead. Yeah, that's why, because if we don't do it manually, I'm not sure we got away from the, we actually did the optimization, because if it has to go through the array, it's linear time again. So that is cubic, back to cubic. And we might want to, think of, so how do you cache? I need to look that up, how to hash an array. Basically, we did solve it, and we probably would have solved it. Yeah, I don't believe when we get that k and we pass it to this map, I don't think it comes there as, and we call, this map calls the, we request here if this value is in that map, and how many, what's the, it's the key, if the key, so the key is there, and what's the value. I don't think this thing comes out as some kind of hash. I think it's an array, and I think it's passed as an array, and then this array is used to create a hash. And unless we create those hashes from the get-go, which could be those hash, so you need some kind of identifier that is unique. Something that says, okay, I'm this. And I'm this. And by the way, each value could be a number up to 6 digits. So we could actually create one of the ideas is to create a string. that will store all these. But again, turning these numbers into a string of string is also a read-only slice of bytes. That's what is string. So it also an array underneath it. So yeah, that's a good question. Yeah, what's the time complexity of comparing, and how to create direct comparison of arrays, and how to create a hash map? And yes, because that will affect. Oh, and how to hash an array? Like, how can we do it if we wanted to do it just manually? Yeah, like a function that will go over it once and create some kind of identifier for it, that unique, the unique hash that is not gonna be repeated. Yeah, it's not gonna be repeated. That will give us constant time. But still, yeah, it should work with cubic, and I think it's probably cubic time here. So anyways, that's a good exercise. We did solve the problem. We have some follow-up questions to look at, and I think that's a good. We have a good hour of practice. We should call it a LeetCode hour. Thank you for watching. Like and subscribe, and we'll see you in the next video.